go ahead and get started. Today we have Justin Kauhl. He is going to be teaching us a little bit about Introduction to Generative AI. I did want to give everyone a heads up that we will be having questions at the end. So if you do have a question, you're welcome to put it in the chat. And then at the end, Justin will get to as many questions as he can. And then if he was not able to get to your question, we can put out a Q&A at the end as well, and send that out with the video. Um, I did also want to say before Justin gets started, at times there's a lot of information that he's going to be giving you. If you stick it out through the end, everything's just going to get tidied up into a neat bow and you're going to be like, oh, that was amazing. So stick through it and he's going to feed us a lot of great information. Justin, if you want to get started, I'll let you take it from here.
Okay, thank you, Savannah. So yes, as said before, I'm Justin Kauhl. I'm a Gen AI data scientist manager at the Dow Chemical Company. So a little bit background on me. I have my linguistics from the University of Hawaii at Hilo and my master's in science in computational linguistics at University of Washington. So I've been doing this work for 15 years for the Dow Chemical Company, 5 years as a contractor under Tata Consultancy Services, and 10 years in Dow proper in the advanced analytics group. For both of those roles, I was a data scientist in the advanced analytics group. So I really haven't changed much in my team dynamic. I've always been a data scientist and I've been doing it for a while. So if you don't know what data science is, it's the sexiest job of the 21st century, of course, by Harvard Business Review. So it's really this field where we combine mathematics and business information and try to arrive at mathematical models that'll help explain the world around us and to help us make better decisions. In a nutshell there. A little bit more about data science, some background here. This is generally the progression curve that we see for most companies as they're getting into doing more predictive analytics or prescriptive analytics. You usually start over here on the far left, which is called the OMG space, which is just you have a crap ton of data and you don't know what to do with it. Eventually, people start getting more organized. They get CRM systems, they get different SAP systems, and they start cleaning that information up, joining it together, and they can actually start using it to do things like reporting. This is usually where we're in what we call the what happened stage on data science. So you're taking historical information that you have and you're providing these reports and you're explaining what happened. But we don't want to end right there. So we also want to know why did it happen. So we can add some additional analytics on there, maybe some market information and do some analyses there and say, okay, well, your sales were down last quarter and this is why. Now, going beyond that, though, we want to start being able to make better decisions. So we start doing things like predictive analytics. This is where we start getting into the AI spaces. So we'll do artificial intelligence, machine learning. We'll develop forecasting models, time series models, things along those lines, where we can say, okay, based on the current economic trends and based on your sales for the last quarter for this particular product, this is where we think your numbers are going to hit. And here's the confidence intervals that we have around that. Here's where we think you're going to be in a year from now. And if everything holds true, we'll do that. And then we'll update those models. And as time goes on, they'll get better and better. Prescriptive is where we say, okay, well, we have all this information that we're predicting. What is the decision that we need to do? What kind of decision do we need to make? And so that's where we'll do something along the lines of scenario planning. If this happens, then we should do this. If this happens, then we should do this. We should put our money into this account and hedge it against that. So that we're in a better position going forward. That all then culminates into what we're calling the autonomous system. So once you have something like that, how do you put it in the hands of people? How do you make it run automatically? How do you make it automatically update on new data or consider new factors? So generally, we work in this space. Most companies tend to sit around here, I'd say. But there's a real push to get up into these higher areas because that's when you're starting to predict the future, right? So before we get in, I'm just going to throw down a little bit of AI terminology here. So artificial intelligence is what we're talking about for the most part today. It's systems that perform tasks requiring some human-like intelligence. So we're trying to emulate some aspect of the human intelligence system, and we're trying to create a mathematical model that will replicate that. Machine learning is a subset of that. It's specifically where we're using annotated data, usually some sort of structured feeds, some sort of forecasts, and we're having the machine learn from that and create its own algorithm fundamentally. There's simple examples of that, usually time series. I can get into some of that later. But then it gets more and more complicated. As the problems become more complex, there become more and more variables to consider, more and more factors that need to be done. We go into deep learning. So this is the same thing as machine learning, except for there's a lot of what are called hidden nodes in there, where the machine is just automatically deciding at each node what kind of algorithm it's going to use and what kind of output it's going to produce. And the entire system as a whole functions kind of like a neural network, like a brain, right? So one neuron talks to the next neuron, that talks to the next neuron, each one of them making small decisions and small changes, which eventually, when put together, creates a system that takes a whole bunch of inputs and then creates a comprehensive output. Generative AI is an extension of that deep learning then, which is this idea of, can we have a very large deep learning network that behaves in a way that generates some sort of content as an output? And so this could be text, this could be images, it could be video, but that's where we're getting this generative AI coming from. So famous models through history, I'll just throw a little bit of this out just to show you that this is nothing new. There's a lot of that conversation that says, oh, well, AI is super new, we just invented it. It's not, it's just a progression of things that we've been doing over time. So when I'm talking about models, I'm not talking about the sexy kind, although they can be sexy. I'm talking about the math kind. But let's see, oops, there we go. So the first actual like electronically calculated sums with the arithmometer back in 1820, we've been working to do that. The problem then was help me calculate sums electronically. Next problem that people wanted to come up with was help me make the optimal decision. So we had decision trees. Another problem is where am I? So we developed Navstar GPS. And the idea here is that we have a problem, we have data, we have some sort of algorithm, and we have an output. In this case, the output is where am I on the planet based on all the input that we're getting from the satellites. ELIZA was created in 1965. That was the first real chatbot. It wasn't super great, but it did take text in, it processed it, and put text out. And it was mostly used kind of as like a fun little showpiece for therapy chatbots. Moving on, beat the world's best chess player. We had Deep Blue, 1997. This was the machine that beat the world champion at chess, right? So they solved chess mathematically. Drive this car for me. This one's fun. Google self-driving cars came out in about 2009. They're still not ubiquitous, but they're around. And they do work. They take input from sensors on the front of the car and they run it through a bunch of math models and they output something, which is instructions for how to navigate the car. The next one here, Win at Jeopardy, was IBM Watson. This was a big one back when I was doing my master's. And the idea was, can we have just trivia questions that are answered by a machine? Draw me a picture came next. We had the generative adversarial networks. These are the ones that were generating the first digital images. So if you've seen a lot of like the AI art that's coming out, this was first started in 2014. And most recently, the transformer architecture in 2017. So it's even been maybe about 8 years since the original transformer architectures came out. And you can see it's been a little while since we've first came up with the idea to when we actually implemented it as a generative AI system. So I'll talk a little bit about how this works at a broad level. So let's say our problem here is we have X number of drums of polyethylene pellets, and how many injection molds for product Y can I run before I need to order more? So, we can start with this. The simple idea is here, we got a bunch of pellets, we have a certain amount, we have a certain amount of volume that we have per product. We can do a simple calculation like this. So X divided by Y is equal to Z. And then we get our output, which is, we can make 13, 20 of these registers with the pellets that we have. Now, this is vastly oversimplified. I know you guys have to calculate the volume of how many pellets you have in the barrel and all of that stuff. But in general, this just kind of shows the idea of what a data science model is doing. So it's taking the inputs, we're creating some sort of algorithm, and we create an output that's static. But it's never really as easy as just simple arithmetic, right? So let's say our problem here is I'm the CEO of an injection molding business. Margins last quarter were down from last year. I need to know what kind of sales to expect for the next quarter and be able to communicate this effectively with my shareholders. So, okay, When we're doing this, let's say, okay, we're going to start with our sales margins. So that's going to be an internal historical feed. We'll have that all broken up by maybe quarter or maybe by month. And it's going to be a time series variable in this case. So a time series variable is just something that you have a data point over time. But just that's not going to be enough. You could say that I believe that the price of oil is actually what's driving up my cost, but they don't know. It could be other factors. There could be a lot of uncertainty in here. And so what we do is we can go in here and we can get some of these other things that we're calling X variables. So the Y variable is what we're trying to predict. X variables are what we're using to influence the model to be able to better predict it. So in this case, it could be anything. I have some examples here of like sales history, volume history, price changes, customer satisfaction, order fulfillment rate. So those would all be internal X variables, and external X variables that you don't directly control, for example, are like global oil prices, where you stand on the competitive market share, what are the product sales. So if we do like a surrogate analysis on one of your products, how is another product that's very similar to it competing in the market? So we can bring this in. It can go on and on and on. I've done models that have 10,000 variables, for example, as inputs. In this particular case, we do something called like an RMX model. So this is an autoregressive model. And the X there stands for exogenous, generally just so, it's using exogenous variables. So that's the X in exogenous. And so there is a calculation that's done here. It'll self-correct and it'll do error calculations over time as it's doing the calculations here so that it can get closer to what would be the ground truth. And the idea here is the output would be some sort of forecast of that information going into the future. And you can get some level of human interpretation out of this. So if I create a dashboard building something like this, we could say, oh, well, sales will continue to be down for the next quarter. And your supposition that it was the price of oil that was driving up your cost is wrong. What's actually causing your poor sales is customer churn from poor fulfillment satisfaction that we can get off of the residuals off of each one of the X variables that we put in there. So we can see the influence of each individual factor when we do something like this. So that said, the algorithms do get quite a bit more complicated even than that. So these were pretty simple examples just to kind of ground you on the idea of data science. But if you've ever heard of this term, the algorithm, these are ubiquitous. They're all over the place, right? So most people interact with multiple of these algorithms now every single day. They're mostly digital constructs. So if you're on your phone or you're doing online shopping or something like that, you're doing something. So in the case of like a recommendation system, so Netflix has metadata for every single one of its videos that you've watched. It knows how many videos you watch, and it creates vector tables and similarity scores between the videos you watched and other ones that might be similar. And so that problem that's solving is what is the video that we can recommend to the person who's watching it now that will most likely get them to engage in our content, right? So how do we hack the individual and get them engaged as much as possible? Google is something that's been around forever now. Everybody uses your search engines. This is also an algorithm. It uses a vector search index where it vectorizes all of the data it collects across the web, and it serves to the end user a recall-based ordered list, which is essentially just this page is the page that is most closely aligned to the query that you provided. And then, of course, we always have, optimization. So what is the optimal temperature I should run this plant or this particular process of the plant at? Have we accounted for vibration? There's some impurities in the input. How do we change variables to be able to compensate for it? It's a very large system. You can put the inputs in at the front, and then you can push out to the output. And then Dijkstra's algorithm is a very popular one just for, travel planning. So MapQuest, and well, MapQuest, that's pretty old, but Google Maps, things like that, planning out your trips. People use that all the time. So back to the examples of the models. So what could be maybe the most complicated calculation ever done? Well, if your problem is I need an artificially intelligent system that can convincingly interact with humans to solve any problem they have using natural language, images, audio, video, etc., that could be a very complicated problem. Your input in that case is going to be the sum total of all human knowledge. The model, in our case, we're using transformer models and things like that, but there's a lot of variability in how you can set something like that up, and the output's some sort of intelligent seeming machine. So I'll digress for just a second here and talk a little bit about the problem of language. So my specialty as a data scientist at Dow is natural language processing. So I have a degree, like I said, in linguistics and computational linguistics. My specialty is doing work with unstructured data. Unstructured data is any data that appears that is not in a standard table format. So you can think of it as PDFs, web pages, audio files, images. Any of that is considered unstructured. It's anything that doesn't exist in like a sales system or a structured table system. Language is extremely complicated. There are hundreds of thousands of words, many thousands of languages. Um, we take it for granted, but generally language is pretty magical. We're essentially communicating information from one blob of flesh to another blob of flesh over the airwaves. And somehow that works. We can convey symbols and understanding and all of that. But when we try to map it mathematically, it gets quite complicated. A lot of that complication is because languages have evolved over time, and sometimes what is immediately available on the symbols is not what they mean semantically and things like that. But there's also a lot of like ambiguity. So, these famous lines here, I shot an elephant in my pajamas. How he got into my pajamas, I'll never know. These statements are funny because it subverts your expectations when you say it because of the ambiguity that's baked into the language. And we got sentences like buffalo, 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 which is actually a grammatically correct statement about buffalo, buffalo, who are buffaloing other buffalo, buffalo. So it gets it's a bit of a mess overall, languages. And so trying to map it mathematically can be quite complicated. So that said, what happened recently, which has caused all of you to be on this call with me today, really. So we've been working quietly behind the scenes for decades on some of these language problems. The thought was that we would have an AI language or solution like this back in maybe early 70s. Never really happened because we underestimated how complicated languages can really be. So what changed? So in November 30th of 2022, OpenAI launched what they're calling ChatGPT. Now, the technology that they used to create ChatGPT was not exceptional. Google actually developed a lot of the language. They published a paper several years earlier. People were talking about it. It's growing out of some of these larger deep learning models that they had developed. What the difference here is that they made this publicly available and it worked well. And so it really got that viral sensation and people got really excited. And so people started emulating, more money flowed into the system, more funding went out for AI research, and now we're kind of in this AI boom. So yeah, some of the things I just mentioned here, but ChatGPT, Google made those first large language models, just to be clear. So Google made the models, OpenAI took them, applied them successfully, and then Microsoft bought most of OpenAI, which is a very interesting situation for Google to be in because they did all the work and then suddenly they're not getting the profits. But that's what the risk you take when you publish everything open source. One of the things that really surprised people is it seems to know everything. And this is because it was trained on just a massive, 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 massive amount of text that was available. Some people are also saying, it's growing smarter on a day-to-day basis. So every single day I wake up and I check things, and for the most part, it's getting smarter. There's a lot of small companies and things like that are really trying to push the development of this. The big companies seem to be a little bit more interested in just kind of sitting back and letting the money roll in right now. But I think we're kind of on a trajectory now for this technology to start really accelerating. So what we're seeing in a lot of this generative AI solutions is that there's a lot of different versions of it. So we have text-based, which is mostly the OpenAI, image-based. We've got several different ones like Stable Diffusion, Midjourney, etc. Audio-based ones, 11 Labs is an interesting one. I've not really worked with them much. I don't do a ton of audio processing, but they can create from just very small voice samples of people, very convincing transcripts of those people saying stuff like that. So that's where there's some concern about deepfakes and scam calls and all of that, just to be aware of. Video-based as well, VO. If you've seen some of the new demos on VO3, it's really quite impressive. If you haven't seen anything on VO3 yet, maybe take a couple looks on it. It's 100% AI-generated video content that has now synced audio with it. So it looks like someone just took a film and it's completely fake, but it's crazy. And then the mixed modal is where we're going. Most of these things are going to be going towards a mixed modal model where we're going to get more text, image, audio, video, all inside the same model, and it can intelligently switch tasks between them. So that said, I put in some prompts just around RVWA, and this is the summary it gave me. So this is generated from external information. It's whatever is publicly available. And when it replies with things like this, generally what it's doing is it's pulling from its neurons, its own internally learned information to generate this. In this particular case, I don't think that's exactly how it happened. And I can get into that a little bit more, but for the most part, we can just ask it a prompt like, what is the RVWA, which I think is the prompt I used in this one. And it gives this nice summary. It's really great. It's comprehensive. It gives you a whole bunch of information. Also, we can do the same with images. So I did a couple of them for here. I said, just generate an image that best represents the RVWA over here, which I think is a kind of nice logo. And then generate an image of an AI camping. So you can just have fun with it. A lot of the uptick in adoption has really come from individual users who have ready access to these tools and they just think it's fun. And as they use it, all of that information can then be collected and used in later steps to actually do training, but I'll get into the exact details of that. So that said, let's play a game. And this game is called Finish the Phrase. And this is here to help you understand how the large language models are actually learning information. So if we have this one here, I pledge allegiance to the blank of the United States of America. In your head, you probably had a word pop up, and that word was probably flag. You can't handle the blank from A Few Good Men, the movie. This one's a little bit more obscure, maybe, but truth, most of you probably had that word pop up in your head. And here we have one from Jaws. So we're going to need a blank boat. So there's a lot of different words that could potentially slot in there, but in this case, it's bigger, right? So I want you to think about this as an analytics problem or a data science problem. So the problem here is fill in the blank. So how did you perform on this particular little game here? But more importantly, how did you do it? How did your brain fill in that blank? There are, like I said, hundreds of thousands of words. You didn't just randomly pick one of them, right? There's context clues. There's words that come before, there's words that come after. There's some context here about what I gave you there. There's experiences that you've had. That is all encoded in memory. And that memory is encoded in your neurons. And that's the system that we're trying to emulate when we're developing a large language model, right? And so when we do something like training a language model, it's very similar to ad libs, right? So I don't know if anyone's played these, but I used to love doing these when I was a kid. And the idea is that there's a bunch of blanks and you got to fill it in. And so what we'll do to train these large language models is we get as much data as possible. So tons of books, tons of web information, like GPT-3, I think, was trained a lot of Reddit information, a lot of Library of Congress books and things. And we want to encode all of the patterns that we see in there as math. And when I'm saying patterns, I'm saying things like the word bustling comes before the word city in this case. And we'll just put a 1 next to that and we'll move on. Or the word city is a noun and we'll put a 1 next to that. And we just keep doing that. We get statistical mathematical models, representations of all of this information. And it's just, like I said, it's an absurd amount of information. Most of these have billions and billions of parameters. And parameters is the term that we use to describe these specific features that we've been able to extract out. So when we do that, we encode all of that as math, and then we take maybe a sample bit of text and we blank out some of it. And we say, okay, guess the missing words, and then calculate the error that you had. So we have the ground truth. We have the test that we give the newly formed AI. We say, okay, fill in these, and it'll fill it in to the best of its ability, and then we'll show it the answer and say, okay, check your own work. And it'll go back and say, okay, well, I got this one right, I got this one right, I got this one wrong though. And so it says, okay, why did I get this one wrong? Let's correct the error. So they'll tweak the weights on each one of these features so that next time it does it, it's a little bit better. And they'll just do this over and over and over and over again until we can get something like a Chat GPT. right? So a chat GPT is a large language model. It's just large because it uses an absurd amount of input data. Normally, when I would be doing language models by myself, I would have access to maybe 10,000 documents or something like that. Large language models are working on the scale of billions, maybe trillions, petabytes of information. For example, GPT-3, was about 60% common crawl information. So that's just general web crawling. So stuff like picked up from Google, the Google search stuff. And we have a bunch of Reddit data. We have a bunch of books repositories and then a little bit on there on Wikipedia. And when I'm talking about what the model looks like from a mathematical standpoint, it has 1.8 trillion parameters in GPT-4. So I just shifted to the next model, but 1.8 trillion parameters across about 120 layers. And when we say layers, it means these things over here. These are like the hidden layers where each one is responsible for taking a particular subset of inputs and making a particular decision or doing some sort of mathematical process and then outputting another piece of information that is used then as an input for the next layer. And so you can think of that 120 layers deep. It gets quite complicated at that point. But essentially what it's doing is it's predicting the next word in the sequence. So given the context of these words here, what is the most likely next word? And if we look at this right here, so it says there's a 4.5% chance it's learn, 3.5% chance it's predict, and it goes all the way down until it completes the 100%, right? Where there's a huge long tail of astronomically unlikely words that could go there, but this is the most likely word. And so it'll output that. Now, what prevents generative AI from becoming extremely deterministic in that it will always produce the same response no matter what, is that there's always like a little random factor that's added to this and says, okay, well, this time maybe don't take the first one, maybe take the third one, maybe take the fourth one. As long as it's up in the top here, it'll generally take it. And that's how it looks like it's being creative. So it'll create you a story that you've never seen before because it's just sometimes in there, it's just throwing in some random words and then it's building off of those words. And so there's this concept of self-attention, which is essentially just as it's generating its own information, it then uses its own outputs as its next tier of inputs. So, all right, that said, large language models themselves are pretty good, but why does my chatbot get my technical details wrong? It's like I gave it specific instructions and it didn't tell me the answer. There's a lot of reasons for that. The number one reason is usually it did not learn anything about what you're trying to ask it about. Maybe it's specific to your particular company. Like, why did this particular customer churn? It doesn't know because you didn't publish it on Facebook, right? So it didn't pick it up and it didn't learn it. So there's a little bit of that goes on. Generating incorrect information or making up an answer. This has been dying off a little bit. It's not as bad as it used to be. The first models had a lot of hallucinations because, like I said, it was just randomly generating some terms and things at times. And then it kind of built off of that and it went weird places. Like I said, large language models generate the next most likely word using past observations and context. And then there's this concept of the stochastic parrot. So stochastic parrot generally just means that it's not a living thinking machine, right? It's not it's not intelligent. We call it AI, but it's not really intelligent. The idea is that it's just a mathematical model that is parroting how a human would talk by using mathematical weights. And this isn't just some stock image. This is actually my old professor from my master's program. So that's Dr. Emily Bender. She just got featured in Times Magazine as one of the top 100 people in AI now. So congratulations to her. She's not a huge fan of large language models, but that's another thing. But okay, let's address that first point. So it doesn't know my data. How do you work with it then? Like, what's the point of using a large language model if it can't help me with my very particular situation, my very particular data? Well, this is the concept of a RAG. So there's been a lot of talk about, oh, well, we'll just make our own large language model and things like that. You don't want to do that. They're very expensive. You'd have to generally get access to a bajillion documents and then tons of server space and then run it forever. And this is where the real costs of training these models comes from. People complain about the costs of using generative AI. It's not the cost of actually running it most of the time. It's the cost of training it. So it takes a lot to train it. So we don't want to do maybe the build. We can do some fine tuning, which is essentially like modifying some of the neurons at the end so that it's a little bit more specifically trained to your task. That's getting better. but I tend not to use it. Reinforcement learning from human feedback is a pretty common technique that people use. It's how people or how the companies have been refining the models, where they're taking input from experts and things and having it correct itself based on the errors it's creating. But really what I want to talk about is this last one here, retrieval augmented generation, the RAG. So I'll explain this one by using an example. So this is a project that I actually did. The idea here was that we had people in our employee health and safety group who were really interested in understanding some of the root causes behind safety incidents that were happening in the plants across the world. But there was so much data, they just didn't have the time and energy and manpower to be able to do anything with it. So we proposed building something like this, which is called retrieval augmented generation. So normally what you do is you chat. The chat will go to the OpenAI and it would output some sort of response, and then you'd populate it over here. In this case, what we're going to do is we're going to take all of the internal data that we have, we're going to put it into a search engine, and we're going to have the chat bot here basically just reach out to the search engine and say, okay, get the most likely articles that are relevant to this and add that to the query. So in the context of some chunks of information that we pulled out of our massive database, answer this particular question and then pass it over to the large language model. That works really well, actually. So you're basically just saying, okay, go take this test, but it's open book. So it really helps. It's a way of very quickly searching through huge amounts of information. And we've got several of these applications now running on different processes. So maybe like sales or something. Oh, well, what was most recently happening with this particular customer? Well, it goes into your database and it pulls out the correct information. It supplements it, and then it passes the large language model, and you tell the large language model, hey, interpret the current status of this customer in the context of all of this data that we have. And it comes out with a really nice response. So I like RAG. I think it's a good thing. It's kind of a hack because it's not really like a pure math model, but it works. All right. So that said, using Gen AI, there's some examples and things. There's some general guidelines. So you probably all have access to some form of generative AI now, free or otherwise. And there's a whole context, or there's a whole chat about prompt engineering. How do you do all that stuff like that? I really don't think prompt engineering is like a future career path for anybody, but fundamentally, it's good to understand how these systems work and how to effectively interact with them. So, you'll want to provide clear objectives, provide quality input, and then sometimes it's just not going to come out even when you do everything correctly on that. So you'll probably want to experiment and iterate. Usually these chatbots, what they're doing is they're creating a chain of messages as they go forward. And that chain of messages is actually packaged together and put into the next prompt when you type it. So it has historical context about what you've been talking about. If you close this chat window or something like that and start a new one, it won't have that context anymore. Something to be aware of. But you can experiment and iterate and say, okay, well, you got that wrong, and this is why I think it's wrong. And it'll use that in context of all the other information you provided to create a next version of it that's much better. Understand the limitations. Like I said, it's generating the next word in a sequence. There's some amazing things it can do with that, but that's all it's doing. So if you ask it things like, calculate something or make some sort of higher order reasoning decision, it's not going to work as well. There's new models that are coming out called reasoning models that are specifically designed for that. But usually what it is that they're passing that task off to another model. This is called agentic design. And that model will answer the question and return that to the original large language model. And then the large language model will push it out to you. So, and then lastly here, stay updated. The Gen AI technology is rapidly evolving. So you want to, I don't know, it's hard for me even. I work in this profession and I go to sleep and I wake up and the world's changed. So, at least in broad strokes, try to keep up with it. We're going to start seeing a lot more of this, which is embedded large language models and generative AI technology in all of our devices. I liken this a lot to like the computer revolution where one day we're all doing things on paper, and then suddenly the next we all have computers, and it's an expectation that we're using computers. This is probably what's going to happen here. So if you have Microsoft now, the new versions are all coming out with this little Copilot button. That's what they're calling their branded model. And it appears in all of the M365 applications. Again, with the prompting tips here, So, make sure you specify your goal, make sure you specify some context on it, sources, expectations. It's really an easy way of thinking about this is imagine you just picked up like a fresh high schooler off the street and you put them to work in your company. Maybe they're the smartest high schooler in the world. They have encyclopedic knowledge about just general things, but they don't know you. They don't know what's going on. They don't know what the problem is. So you got to be kind of real specific about it. You can't just throw some vague clues at it and hope it comes out with a good thing. I've actually seen in our company a lot of people doing structured queries, which is essentially you get like a JSON document and you break it all down into individual bullet points and say, this is the question, here's the factors, here's the acceptable answers. You can write this thing out to be like a huge essay. And if you want to do something really complicated with it and want it to act very reliably, it's a great way of doing it. I've seen some very impressive results out of that. So another thing I want to cover is just some general AI misconceptions. So you guys have all been hearing about Gen AI and all what's been going on. But there's a lot of things that people don't always get straight. So like I said earlier, generative AI is not a new technology. It's just a next step. It's just a slightly more complicated model than when we had 5 years ago. AI is learning from me when I use it. This is not true. So this is one of the biggest misconceptions I see. Now, there may eventually come a time when it does, but what we're seeing right now is not AI learning from you. It's got a core, a foundational model is what they call it, and it will answer from that information. And maybe the company that you're sending this out to will collect your information and use it for the next round of training, but it doesn't automatically learn anything. You can't have your own custom AI model generally. You might be able to have a layer on top of the foundational model that someone will provide to you, but the foundational models are always going to be like the same dozen or so. Generative AI will replace true human creativity and innovation. This one's a hot button issue. A lot of people out there debating it. From a mathematical standpoint, I can say that it is not AI. It's not intelligent. It's not creative. It's not doing anything. All it's doing is reproducing patterns. And as long as all we want is more of the same pattern, then it'll be fine. But there's going to come a time when, we'll need true creativity, and that's where humans are still going to excel. It's impossible to distinguish human content from AI content. The gaps are closing. It's harder and harder, especially if you're not paying attention, but there are still signs. There's artifacts that usually appear in it. Like the M dash is being used a lot right now as a marker for whether or not something was a language block was generated with it, because nobody uses M dash. It's not even on the keyboard. So it's a weird one. And generative AI is better than human workers. This one, in select areas, it's going to be more efficient to use generative AI than it is to use existing processes. But the key thing to keep in mind here is that humans with AI will replace humans without, just like humans with computers replaced humans without computers. So it's just a new tool, and it's more effective. I wanted to also cover a little bit tips for handling AI vendors, because I deal with a lot of them. They're ubiquitous. They're all over the place, and they all want to sell you something, and it's crazy, and they're driving me nuts. And I just want to stick it to them. But yeah, ask what foundational model they're using. Specifically, use these words: foundational model. They're going to answer something like Llama from Meta, GPT from OpenAI, Gemini from Google, Claude for Anthropic. There's a couple others, but generally those are the main ones. If they don't understand the question, they can't answer it, it's a huge red flag, because they're all using a foundational model, even if they try to tell you that they're not, because they cannot fund their own generative AI build. Just like I said, they need tons of money and nobody's going to do that. If they're selling your own custom model, it usually means either retrieval augmented generation, which is the RAG that I talked about, or some level of fine tuning on your data. There are costs associated with running these, more so than just the generative AI. It's not going to just be a token cost. You're going to also have to run a search engine. You're also going to have annotated data. It's a little bit more expensive than they're going to make it sound. Data security is a huge concern for my company and a lot of companies out there. So make sure you're clear on whether or not they're pushing your data out to some other third party, or if the data is going to stay in your ecosystem, if you're going to host it on the cloud, just be clear on those things. Past success stories, like usual, look to see whether or not they've done this before. There's a lot of companies out there that have never done any of this before, and suddenly they think they can just be the world's best tech startup. So buyer beware on that one. And then regulatory compliance. Some of the European countries are banning the use of this. There's some talk about some states that are doing the same thing. Make sure that they're in charge of that, because you do not want to get into the legal landscape. I've spent too many hours talking to lawyers on this, and my eyes glaze over. So, they're going to figure it out eventually, but not today. And I think this is the last thing I really have for you guys, is just some ideas about the future of AI in the RV industry here. So there's a lot that goes on behind the scenes now with computers and things like that. And sometimes you don't realize it's our AI, sometimes you do. But I see a lot of the use cases. My job, mostly people come to me with the ideas across the company, and I do some process to try and vet them. And I've seen a lot of really good ideas. I've seen a lot of bad ideas too. But in the RV industry, this is my thoughts. So, the trip planning and navigation is going to get better. So we already have things like mapping programs and things like that. But now you can just ask it, hey, I want to go to a trip to so-and-so place. Suggest some stops, attractions, and then plan it for me. So that's going to be more and more common, I think. I was doing some of that to plan out a trip to Japan, which I thought was really cool. Predictive maintenance and diagnostics. So we're using AI tools now in the plants to identify things. We have tons of sensors on all of the chemical processes, and all that information is being fed into a central system. And we can use now generative AI to help break through some of the bottlenecks we had on developing traditional models to address some of the problems we had. So there's some statistics on here, which I grabbed from this. So just so you know where those are all coming from. Smart features in vehicle assistance, those are all going to become more common. Pricing and market insights is a space that I work in a lot. So you can use it to scan external information. I build a bunch of web crawlers, I bring it back and put it into a RAG, and I have it served to the end user, and they can just ask questions against the market, essentially, and they get answers. It's really quite nice. You can also use it to help, change your prices, detect whether or not elasticity is available or not. Some of that stuff. Customer service, this is a big one. Like all the call centers and everything, they're going to try and replace a lot of that with folks or they're going to try and replace a lot of those folks with some sort of AI equivalent. Also, you can use it in your CRM systems and stuff for sales to really help you stay on task when you're a seller. And then there's some sort of AI transformable home that I saw. I don't know anything about it, but if you know anything about it, you let me know. I'd like one. All right, so some more resources and future reading. If you want to go and take a look at some of the sources I used or some things that I thought were interesting, I'll share these slides out to you folks. And I think that's it for me for my really quick presentation that I said probably talked a mile a minute, but yeah.
That's okay. We've got a question already. It says, can you give us some examples of prompts to use that are super helpful? For example, I wanted to make my email more professional or tailored to a room of third-grade students.
Yeah, like I said with the prompt engineering steps, generally, you don't have to worry so much about that. As long as you're descriptive, you describe what you want, what the scenario is, and maybe you can give some examples. That's maybe the only advice I'll give is provide some examples of what you want, and it can really emulate it. But it's usually smart enough to know what you're getting at. And if it's not on the first try, just tell it got it wrong and keep going. All right, so I did see this question here from Alyssa. If two people ask ChatGPT the same question, will they get the same response? If they set the temperature to 0, then yes, they will get a deterministic response. Temperature is the thing that influences that random variable that I talked about. Now, if you are using the standard settings, which I think they set the temperature at like 0.7 or something like that, no, you're probably not going to get the exact same response. There will be a pretty high chance that at some point during the token generation, it'll pick a random thing that's in a different place, and it will completely change the way that the sequence progresses from there. All right.
Oh, temperature. Explain the temperature a little bit more, because I just found this button the other day.
Yeah, so temperature is really just, like I said, the random factor. So if you set the temperature to 0, what you're saying is I want no randomness in my output. So create only a string of sequences that picks at every single step the most likely word in, from the model, like mathematically. So if we go back, I can probably go back to that particular slide. So like right here. So like let's say this is the table that's generated when it's trying to generate this word. If you set temperature to 0, it's always going to take this one. If you set it any higher, there's a chance it'll pick one that's lower on the list. And if it picks one that's lower on the list, that means that now it's off on a different path. It's taken a fork in the road earlier in its journey, and now it's off generating something that could potentially be completely different. It'll generally stay on task though, because it's not just this sequence that it's referencing your prompt at all times too.
Anybody else have more questions?
Yeah, I do. So, and I'm not sure, forgive me for using the wrong terminology because this is all really new to me. And frankly, I
Not to
forget to
worry.
even explore it half the time. So I'm going to remind myself next time I actually think of, oh, I got to look that up to even try this. But one of your slides showed several different versions, ChatGPT, OpenAI, several other different formats. Is one better than another for somebody that just doesn't quite understand how best to use this new I shouldn't say new, this technology yet.
No, I mean, the applications are new. Maybe the math models are not, is what I was getting at there. So is this the one that you were referencing?
Yes.
So
So
this
I
is,
take it that those are all options that we could use to explore AI.
so they're generally aligned here. So if you want to do something, a text-based task, I would suggest going to maybe an OpenAI. If you wanted to do something that's image-based, like generate me a new image, Midjourney is a good one. If it's audio, it's 11 Labs. If it's video, maybe VO. These are just like maybe the front runners right now on these technologies. So there's tons of options out there. But yeah, that's the idea. It's if you wanted to shoot towards one thing. If you wanted to do something that's maybe like a little bit mixed modal. So if you see the new Microsoft 365 Office plugin for Copilot, you can press that button and you can say, okay, generate me a slide that talks about this and then add some images. So it's doing both text and images. That's what I mean by multimodal.
Okay.
So it really depends on what you're shooting for, but these are good places to start.
That's helpful though. That answers my question. Thank you.
I use ChatGPT.
Do you?
I do. It's very good.
Yeah,
So
she has my OpenAI account, I think.
or OpenAI, yeah, one of the two. So Chris has a question. If seeking data like competitive pricing, will I need to load all of the information first, or will I search the web, or will it search the web for us?
Okay, so that's getting into a little bit of a complicated subject, but so let's say we wanted to do a RAG. So if we pop back to this example here, if what you're looking for is not something that was available at the time of training, then it won't be in the foundational model. It won't be here. So you do have to supplement it somehow. Now you can develop a system to do web crawling and save it all and then do your own vector search and all that nonsense. And that's generally what I do because otherwise it's not available. So you do have to build it out that way. But for a lot of the new tools now, what they're doing is instead of doing all this nonsense, they just link it to the search engine. So like Gemini, if you chat with Gemini, it'll do a RAG operation where it goes to the Google search engine because it's a Google product, and it will pull out relevant information for you and then just automatically supplement it. So it's already doing that task for you, so you don't have to do it. The only time you'd really have to get into the nitty-gritty like this is when you're like me and there's data that's like super highly protected, it's not indexed anywhere, you can't find it, it's not publicly available, then you have to kind of do it yourself. Even then, though, there are new tools with like the Copilot where it's automatically starting to index this in an internal, what they're calling a graph. So it's an internal database that's specific to like a workstation or an enterprise.
So Lori has a question of what personal or professional use do you find it most helpful?
Oh, I love using this for coding. Believe it or not, I do a lot of Python coding. I have been doing it for many years, and I can't remember every single function call or anything like that. What I do sometimes with these new enhanced, what they're called IDEs, integrated development environments, is that I can actually sit there and I can frame out a task. So like say, I would like to develop a website that has these features and does all this stuff and has these calculations that are going on in the background. And I just hit enter. And these new IDEs are amazing. So they'll generate a plan, and then they'll take that plan and they'll use it as input for the next step. And then they'll generate each function in each piece of code. And then they'll interface directly with like the IDE environment to pull in the appropriate libraries and pull in the appropriate data and then bring it all together. And they create a software product basically from scratch. My mind is still blown, and I've been using the things for like 18 months now.
I know our IT guys started using it to write code for custom things within our software. So, let's see. How accurate do you think Copilot through Microsoft is?
There's no Copilot people on the phone, are there?
Nope.
So Copilot, it's using the GPT-4 model, which is a pretty good model. But you have to remember that what they're doing with Copilot is they're trying to democratize it and make it available to everybody. So my organization, maybe we have like 20,000 people. Every one of them has access to the Copilot tool. How does it work in that case? Really what it has to do is it has to like manage its memory effectively. Otherwise, it'll just completely run out of memory if it's going to give top tier answers to everybody. So it's kind of scaled down. It acts a little bit dumb at times. I think what we're going to be seeing in the next few years is that the models themselves will start to become more efficient and miniaturized. Right now, it's just, we're impressed that it works. But in future years, it's going to be like, okay, well, this is small enough now to fit on a phone, or small enough to run effectively on a standard GPU instead of like an A100 from NVIDIA or something like that. In those cases, it'll get better. But right now, as of today, it's probably on the lower end of the large language model performance, unfortunately. But if you also keep in mind that a couple of years ago, we didn't have any, it's still pretty good.
Yeah, I have another question. I got lots of them.
Oh,
So
okay.
I just used it, and some people may find this interesting. A great way of using it is I just created a new catalog and I put the PDF in there and I asked it to find any spelling errors. And it went through and it gave me all these spelling errors and it was great. It told me what page and what was wrong with it, even grammatical, that type of thing. But my question is, I hear a lot from people saying, well, you got to be careful of the stuff you put out there. In other words, the catalog wasn't anything top secret, right? So if I put something in, Chat GPT and it would be historical sales or whatever, does it keep that? Does it make it like,
Right. Okay. So
done?
this comes to this point here. AI is learning from me when I use it. So the AI itself is not learning from you as you use it. However, if you send data out to another company, and that company is the one that's running the large language models, which is how these work. Like you send the data in a packet, the packet arrives, it is unpacked, and it's sent to the large language model, it gets a response, and it sends it back. The AI doesn't learn, the AI doesn't save it, but the company that's running that AI might. They might have a process that just says, okay, for future training purposes, let's record the input and the output. And then that gets added to a large database, which is used for the next round of training. And you might see like the little thumbs up, thumbs down buttons on some of the responses and stuff like that. They use that to help calculate the weights. So really it's a question of, are you comfortable with sending this data to that company? Yes or no?
Okay, and if you're not, that's where getting a company that can provide you your own, not personal, but using the RAG, I guess, the foundation to build on, to customize is where you would want to use that because then it doesn't send it out, correct?
No. So the RAG is still going to be sending it out generally. So I'll tell you what Dow does. So essentially, we have our own instance of this model. So it's a foundational model. We have GPUs and a compute system that runs that model, and we control the environment. So when we send things to it, it just executes and it sends it back. It doesn't do anything funny because we own the entire environment around it. But if you're using open source ones or publicly available APIs, you've really got to read the fine print on what they can and can't use for training going forwards.
Okay. I think, let's see, I'm looking through, sometimes I find links it gives me are either inaccurate or not available anymore. Is that just because the stage AI is at, or the question am I asking?
In that particular case, I would blame the search engine. So what it's doing is searching, well, okay. Let me dial that back a little bit. So you can think of this as the models are trained, and that training is basically frozen in time. Now, if it's not doing a RAG, if it's just a direct connection, and you ask it a question and it comes back with a response, that response might be several years out of date, depending on how old that model is. When was that all that math frozen in the algorithm, right? And so all those references might have been from 2 years ago, and that page is no longer existent. The other side of that is if it is using a RAG, maybe the search engine that it's using is not up to par. People like to cheap out on this one because it's invisible. So they'll use some crappy elastic thing that they just threw together themselves instead of using like a big proper one like a Bing or a Google. And in that case, whoever's maintaining this might just be populating it with bad data, and you can get some funky results on that.
I got another one here. How accepting are the US consumers of using AI generated imagery?
That's a hard one for me to answer, to be completely honest. I guess question one is, are they aware that the image is AI generated? You probably encountered one today that you didn't realize was AI generated. So that's going to be the problem overall. If they knew it was AI generated, it's pretty split. There's a lot of people who are aggressively anti-AI, but I don't know. It's an ongoing thing that's kind of evolving.
Okay. Anybody else have any questions? I know it was a lot of information.
I know I
It
information
goes-
dumped a bit.
No, that's okay. Wow. And I know it's just the tip of the iceberg too, but I hope everybody today got a good knowledge base of what AI is, where it came from, that it's here to stay. And I personally love to use it, um, and I'm still learning every day. So we
Yeah.
really appreciate you being here today. Thank you, Justin, for your time today and this very helpful presentation. And next month, our presentation is on personal finances. So if you haven't signed up for that, you are more than welcome to jump in. And Savannah, do you have anything else to add?
I do not. I just want to, again, like you said, Susan, Justin, thank you so much for your time and all of the knowledge.
Happy to be able to share it with you guys. And I guess my parting words are AI is just a tool. And whether or not it's used for good or evil is kind of up to whoever's using the tool. So we'll see how that all develops going forward.
Hopefully, only good.
Only
Be
good, right?
optimistic. Yeah. Well, thank you everybody for joining us. And Justin, once again, we'll see you next month.
All right. Take care, everyone.
Bye.